Now, the next important design principle is open closed principle, or in short, OCP. This principle states that software entities, that can be classes, modules, functions, etc., should be open for extension but closed for modification. This means it is open for modification but closed for open for extension but closed for modification. This means we cannot modify the existing classes if new features come, new requirement come from users, and your class allow the changes. So it means it is not following the OCP. So it will be better if we bring if we close this code for modification and extend it. So when new features come, we will rather extend it. The closed part of rule states that your code is closed for further modification, and open part says you can add new functionality without affecting code of existing class. It means you should be able to extend the functionality of class, module, or function by adding more code without modifying the existing code. Why we use OCP? Now the important question arises. So there are certain benefits we can achieve with the OCP. The first is enhanced maintainability. By applying the OCP when changes are needed, that can be by adding new features, developer can extend existing code rather than modifying it. Remember that modification of existing code is very difficult. It can be easier if the developer who by himself develop that code, implement that code. So that can be easier. Not necessary it is easier, but can be easier for that developer. But if someone else want to modify it, it can be difficult. There are some other reasons also, because when you are trying to modify the existing code, it is possible that you bring successfully the new changes, but the addition of the new code can bring errors or bugs in rest of the code. So this minimizes the risk of introducing errors or bugs into already tested and stable code, making the system easier to maintain over the time. So another associated property that makes the system more maintainable is the flexibility. OCP allows developers to add new functionality without altering the existing code. This flexibility means that system can adapt more easily to changing requirements, which is especially important in agile environments. You know about agile requirements, agile environment, agile methodology, or agile development, where changes are expected, abrupt changes, continuous changes, and integrations are expected over the time. So this means you need a simple and flexible design. So if we talk about the simplicity or flexibility, so how we can achieve that? So OCP is one of the design pattern that make it possible. Reduction in code duplication. When following the OCP, developers can create new classes or modules that extend the existing ones rather than duplicating code. This leads to a cleaner code base and reduces redundancy, making it easier to manage and modify the system. It encourages better design practice. Facilitates testing. When classes are closed for the modification, the existing code can be tested separately from the new extension. This means the extension, although it is the part of that system, we extend the existing code, but both of these can be tested in isolation. This isolation helps ensure that tests remain valid and new features or changes can be tested independently, simplifying the testing process. It promotes reusability. OCP encourages the design components in a way that they can be reused with the new extensible features. This not only saves development time but also leads to a consistent and coherent architecture. It brings collaboration, more and more collaboration. Collaboration become easier in a team setting. OCP allows different team members to work in a various extension independently. Up to now, you must learn that OCP talks about the extension. Modification is the part. Okay, sorry, change is the part. Change is the part of the every system. Okay, and many methodologies like agile welcome embraces the new changes. So change is expected. But what do as you see OCP tell? OCP tell us that we should extend the code. So if we make the software in extensions, so this means it bring collaboration, and collaboration is a part of the software development, especially when we talk about the global software development or distributed system development. In distributed software development, different teams or team members are separated across the globe and they work together on the same system. So when we talk about the extensions, this means we must we can assign these components to different developers who work parallelly on the same project. Since the existing code is not affected by these extensions, multiple developers can implement and integrate new features more effectively without stepping on each other's toes. Better code readability, and this means readability, understandability. We can also say understandability. By keeping existing code intact and introducing new functionality throughout extensions, code can become better organized, making it easier for developers to read and understand how system is evolved. So this means with OCP we achieve most of the quality attributes and non-functional requirements of the software system. Now see to this example in a detail. So this is the customer discount calculation. This code is written for discount calculation in Due C++. So this code, first I will explain you this code which follows the OCP, and then the same code with the same purpose but without OCP. So I will also explain that part. First come, now I will explain this code in a quite detail, so anybody who wants to apply OCP to his code must understand it. So remember the OOP concept, the object oriented programming concept, is mandatory for applying any principle. So this is the class customer. So you can see here we have class customer, okay, and inside it we have public, virtual, string get type constant is equal to 0. Customer is an abstract base class that defines a common interface for all the customer types. You know abstract class. Abstract class is a class which does not include the implementation, concrete implementation, but rather the derived classes do the implementation. The get type method is a pure virtual function, meaning that it must be overridden by any derived class. Okay, this makes customer an abstract class which cannot be instantiated directly. So you must remember the purpose of using the virtual word. So it must be overridden by the derived classes. Okay, if we see here class regular customer premier customer and VIP customer. So the implementation purpose of all these classes same, but the names are different. Okay, so this one class regular customer, uh, these are the concrete subclasses of the customer, concrete classes which I talked earlier, when I was talking about this abstract class and virtual function, that it will not be implemented here but rather in the derived classes or inherited classes. So these are the concrete subclasses of customer representing different customer types. Each class overrides the get type. You can see each class overrides the get type function, okay, to return a different string which correspond to the customer type, such as in this case regular, premium or VIP. The override keyword ensures that the method is overriding a base class method. If there is any mistake, the compiler will generate an error. Okay, so all of these class are derived from this abstract class, but difference is that it is for regular customer, premier customer and VIP customer. Now we have another abstract class. Okay, abstract discount strategy class. The discount strategy class is an abstract class that defines the interface for all the discount strategies. Now we define, just like when we define different customer types, here now we define the different discount strategies. So this discount strategy class is an abstract class that defines the interface of all the discount strategies. It has a pure virtual function which is meant to be overridden in the derived classes. This method will calculate the discount based on the customer type or strategy. By using the strategy design pattern, we can change the discount behavior without modifying the existing code. So here we will talk about the OCP. So we can change the discount behavior without modifying the existing code. Okay, so when we see here we have further three classes: class regular discount, premium discount, VIP discount. Class regular discount is a discount given to the regular customers, and premium discount is discount given to premium customers, and VIP discount is given to VIP customers, and so on. So when we see here regular customer discount, so this is the derived class from this abstract class, which is the discount strategy here. So all of these three all classes provide the specific concrete implementation of calculate discount concrete implementation of this discount strategy class. Okay, so these method provide implementation of calculate discount. So all of these, if we see all these derived classes, we have the same method calculate discount in all of these derived classes. Okay, but the percentage is different. Here you can see it is returning amount which will be passed here as a parameter multiplied by 0.05, 0.10, 0.05. So the override keyword ensures that these methods override the abstract calculate discount. Here is the calculate discount method in the discount strategy abstract class. Okay. Then we have another class. So you understood we have two abstract classes and 6 derived classes, so belong to different abstract classes. Now we have another class discount calculator. Okay, the discount calculator class is responsible for calculating the discount It uses the composition by accepting a discount strategy pointer. You can see a discount strategy pointer. Okay, here the calculate discount function delegates the discount calculation to the calculate discount method of providing strategy object. By using polymorphism, this function can work with any type of discount strategy, such as regular, premium, VIP, without knowing the exact type of strategy. Okay, so this is the discount calculator, and this is the pointer to the base class discount strategy. Okay, and then we will come to the if we can further see. If you don't understand, I can also further explain it if we break down the code. Okay, so we have the constant discount strategy, steric strategy. Okay, so the discount strategy, if we see, the discount strategy is an abstract base class that defines the common interface for all the different discount strategies, such as regular, discount, premium, etc. The steric strategy, if we see, the steric strategy is a pointer to an object of the class that derived from the discount. This discount strategy. Since the discount strategy is the base, the pointer can point to any object of its derived classes. Laterally, we will take the objects and will pass it here. Okay, so then all the derived classes based on the specific type will implement it. Constant before the pointer means that the function promises not to modify the object that the pointer is pointing. The function can read from it but cannot change it. This allows the discount calculator class to work with the different types of discount strategies without knowing the exact type at compile time. Okay, and if we see the double amount, this is the amount on which the discount will be applied. That is the total purchase amount for the customer. The value is passed to the calculate discount. Okay, this one discount function of the specific strategy to compute the discount. Okay, and then we have a strategy calculate discount amount. So this sign, this is the in C++, this operator is used to call a method on the object that pointer strategy is pointing to. This is a polymorphism in action at runtime. The correct calculate discount method will be called depending on which the derived class is the strategy points to. Okay, the calculate account function in the discount strategy class is a pure virtual, meaning that it must be implemented by any derived class. Each derived class provides its own logic for calculating the discount. For example, 5% for regular, 10% for premium, 15% for VIP customers. Since strategy is a pointer to discount strategy, it does not matter which types of discount strategy object the pointer points to at runtime. The appropriate calculate discount function implementation will be invoked. Okay, now come to the main function. The main function demonstrates the use of the discount strategies. We create instances of regular discount, premium discount, and VIP discount. So these are the instances, objects created with the same name of these classes, and we have created a discount calculator instance with the name calculator. This means calculator is the object, instance or object for discount calculator class. When we then create a discount calculator instance which is used to calculate the discount for each customer type by passing the corresponding discount strategy object. This is important. For each customer type, we print the calculated discount for purchase amount of 1000. So you can see calculator, which is the instance of this discount calculator, dot calculate discount. If we see, calculate discount is a method which is called, and we have passed this object, and regular discount and premium discount, and so these three different objects are passed, and we can with different values, but the percentage will be different. So this means it will be passed here and depend on the discount strategy. So here you can see it is for first is for regular discount. Regular discount is object taken for regular discount. So here this object will come here and pointer point to, and we have regular discount, premium discount, and VIP discount. It will be calculated accordingly. So if we see how this code follows the open close, the OCP is followed primarily in how the discount calculation logic is structured. Let's break it down by step. So if we see extending discount strategy without modifying the existing code, if we see we can extend the strategy without modifying the code. So we have different strategies: premium discount, VIP discount, regular discount. If we need another discount or another type of customer, so we can easily extend the code without modifying it. The specific discount calculation for different customer types are implemented in derived classes like regular discount, premium, and VIP. Each discount strategy is encapsulated in its own classes. These classes each define their own specific discount calculation logic. New discount strategies can be added easily by simplifying, creating new classes that inherit from discount strategy and implemented the calculate discount method. For example, if you wanted to add student discount, you could create a student discount classes that implement. So you can add another student discount class easily. Okay. If we see another point, the discount calculator class is closed for modification. So the discount calculator class defines a method of calculate discount that calculate the discount using any strategy or any new strategy you add in future. So the discount calculator is closed for modification because once it is written, you don't need to modify it to add new discount strategy. The method calculate discount will still more work correctly with any new class that implement the discount strategy interface. The flexibility comes from the fact that you can extend the behavior of the discount calculator by creating new discount strategy subclass, but you don't need to change the discount calculator class itself. The logic for calculating the discount remains the same regardless of the strategy. So no need to modify the discount calculator for a new strategy. The discount calculator is designed to work with any type of discount strategy since it relies on the polymorphism. The actual method for calculating the discount is determined at runtime based on the type of discount strategy object passed to it. So this was I think enough explanation, but if we implement the same code, if we see same code is here, but this is without following the OCP. You can see customer, regular customer derived from public customer, premium class customer derived from customer, and VIP customer derived from the customer abstract class. And we have class discount calculator, and we can see here we have double calculation discount. Okay, so what is this? This is a pointer. Okay, pointer steric x for the class customer and amount. So if x points to get type is regular, so all of these conditions will be checked. If the return type of this customer is regular, so this amount will be paid, and if it is premium, so this will be given, and if it is VIP, so this will be given. And then we have int main. We have these three instances belong to these three different customers, and then we have discount calculator, okay, and we have calculator instance. So the same logic is implemented here, but rather than taking a separate derived classes which shows the the derived inherited classes, we have implemented this logic inside the calculate discount class here. Okay, so working is same here, but what is the problem? It is open for modification, okay, not closed for modification. If we bring changes like I have stated and explained earlier, such as want to add new customer and new discount strategy, so here, although we will here in this case we will add new customer derived from this public customer, but we will put another condition here, else if. So this means it is open for modification, unlike the previous case where this code is closed for modification and open for extension. So by using OCP, we can achieve the qual attributes as I have explained earlier. So this was all about the OCP. Thank you so much.